Hi everyone, I hope you're all keeping safe. I've been asked again to make a video of the solutions to the answers that I've set you this week. Okay, so I'm going to do some of them as videos and I'm going to do some of them as me talking over the questions on the Word document. Okay, so the first question I've asked you to do is question 18. In this question, you are told that all of these molecules have got polar bonds. Okay, so they must all have polar bonds because they've got different atoms joined together by covalent bonds. So if they're different atoms, they're going to have different electronegativities. And if that electronegativity difference is bigger than 0.5, then they're going to be polar covalent bonds. So what we've got to identify here is which one is a non-polar molecule. Now, they're non-polar molecules are symmetrical. So we need to look at the three molecules up here and find out which one's symmetrical. Okay, so A is clearly not symmetrical, so it's not A. B, although there is some symmetry between here and here, there's no symmetry across this way. Okay, so that is, the water is not a polar molecule. This one, carbon dioxide, is a polar molecule. Okay, there's symmetry in both directions. Okay, so the answer to this one is C. And if we look at D, trichloromethane, there is symmetry across this way, but there's not symmetry across this way. Okay, so it's not D either. Okay, so the answer to this one is C. Okay, question 20. I've had to use my brain here to memorize a few things, and I've written the question out slightly differently. In this question, you're asked which of the following would have an electron arrangement of 2,8 and be positively charged. Okay, so A is neon. Neon has an electron arrangement of 2,8, but it's not positively charged, okay, because it's an atom. Fluoride, or the fluorine ion, has got an electron arrangement of 2,8, but it's negatively charged. Sodium atom has got an electron arrangement of 2,8,1 and it's not positively charged. Okay, Al3 plus is positively charged and it has an electron arrangement of 2,8. So the answer to this one is D. Question 22. In this question, you are given 3 oxides and you're asked to identify the bonding and structure in those 3 oxides. You're told that Na2O is ionic and has a lattice structure. It must be ionic because it involves the bonding of a metal and a non-metal, so it's ionic, and ionic substances have lattice structures. Carbon dioxide and silicon dioxide are the ones that you've got to find out. So these involve the bonding between 2 non-metals in both instances, so they must have covalent bonding in both of them. Now you're told in your notes that compounds of silicon form networks. Okay, so you could have known that from your notes, but if you weren't sure, what you could do is you could look up page 9 of your data book, and there you'll find the melting and boiling points of selected oxides. When you look there, you'll find that carbon dioxide has a very low melting and boiling point, and silicon dioxide has a very high melting and boiling point. So what that tells us is the type of bonding in silicon dioxide is likely to be covalent and a network structure. And because carbon dioxide has a low melting and boiling point, we are going to expect a molecular structure. Okay, so question 24, I'm going to talk over this one and I'll type up the answer as I go. I'll put the answer in my own words, which are maybe slightly different from the mark scheme, but hopefully you'll be able to see the link. So in this question, a student writes the following 2 statements. Both are incorrect. In each case, explain the mistake in the student's reasoning. Okay, so all ionic compounds are solid at room temperature. Okay, that is true. Many covalent compounds are gases at room temperature. This is also true. And then he goes on, or she goes on to say, this proves that ionic bonds are stronger than covalent bond. So this is the bit that is incorrect. Okay, so when covalent compounds melt or boil, it is not covalent bonds that are broken. It is inter Okay, so that statement, this proves that ionic bonds are stronger than covalent bonds, is just completely wrong. When covalent compounds melt or boil, it is not covalent bonds that are broken, it's the intermolecular forces between the molecules. Okay, I might add that in as well. Okay, so there we go. That's the answer to the first question. I'll just highlight that in red. The second one, the formula for magnesium chloride is MgCl2. Okay, so that bit is correct. Because in solid magnesium chloride, each magnesium ion is bonded to 2 chloride ions. Now that is not the case. That would be the case if it was a covalent molecule, but it is not the case in an ionic substance. In ionic substances, the chemical formula tells us the ratio of metal ions to non-metal ions. So in reality, there are probably thousands, maybe even hundreds of thousands or millions of magnesium atoms and chloride ions in magnesium chloride, but they're at a ratio of 1 magnesium to 2 chloride ions. Okay, so let's put that into a sentence. In ionic compounds, the chemical formula tells us the ratio of metal ions to non-metal ions in the lattice structure. Okay, so that would get you a mark there for that. Okay, so I'll highlight that. All right. Okay, question 26. This is a 3-mark question, so you're going to have to make 3 separate points to get the marks. In the question, you are told that trichloromethane is 10 times more soluble in water than tetrachloromethane. So you're going to have to come up with some reasons for this. So you should be getting quite good at this, and you should remember from previous questions that this is a polar molecule, okay? This is polar, trichloromethane is polar, and tetrachloromethane is non-polar, okay? The reason for this is because there are polar bonds between chlorine and carbon, and also between carbon and hydrogen, but because this molecule is non-symmetrical, then it's going to be polar. This molecule has got carbon bonded to 4 different chlorines. Each of these bonds is polar, but because the molecule is symmetrical, the molecule is overall non-polar. Okay? The second part of the question, you're going to have to identify what type of intermolecular forces exists between these molecules. So because this is polar, this has got permanent dipole interactions. And because this is a non-polar molecule, the strongest intermolecular force that's going to be available are London dispersion forces. That's right, London dispersion. Okay, so the third mark, you're going to have to tell me why is this molecule soluble in water. So we have to think about water for a second. Water itself is a polar molecule. So that means it's going to be a polar solvent. So because water is a polar solvent, then that means polar molecules are going to be soluble in water. Okay, so that's the answer there. You could write water is a polar solvent. Okay, and then you could write therefore polar substances or solutes are soluble in it and non-polar are not. Okay, so there's your answer there.